Okay. So, how was your guys' OPP? Like, how did it go? Okay. So, was there any point, like any point that you guys faced any difficulty?
Actually, I just forgot to use the skeleton function.
Who is that? No worries, it happens. Like during exam time, it's common to forget about something, so it happens. No worries. So, just give me a second. I have to open the browser. So you guys have the end term now, right? That's all that's left. Yeah. So uh, we don't really have a lot of time left. Like we only have like 3 or 4 more classes. So I'll instead of covering each week individually, I'll just cover which week you guys feel like you have the most difficulty. Okay. So like, do you guys know like which week you guys have faced the most issue? Like, I'm asking you. So which week did you face the most uh, difficulty? Week 9. Okay, the memory allocation is it? Okay, so if it's okay with the others, I'll just start with week 9. Uh, Others, Mohit, Kompal, Suchita. Okay, so I'll just get started with week 9. So is my screen visible and am I audible? Okay. So week 9, it is mainly about the dynamic memory allocation and multidimensional arrays, as we have discussed previously. So let's just get started with the practice assignment first. So I want you guys to answer this, okay? I will only guide you guys when you face issue with some question. Okay. So if you can unmute, that would be great. Otherwise, you can just write your answer in the chat box. So for the first question, which of the following functions are used for dynamic allocation in C languages? So can you tell me which of the four are used? The options are malloc, free, calloc, and realloc. Okay. So yeah, Sushita, it's a multiple correct. The checklist means you can select multiple answers. So yeah, malloc is correct, but calloc and realloc are also correct. Free, it is debatable. Actually, no. Free is not used for dynamic memory allocation. It's used for freeing the memory or making it available. Okay. So ACD is the correct answer here. So Syed, you're correct. So after that, which of the following statements is slash are true regarding? Okay. So before moving on to the next question, I'll just ask one question. Can anyone tell me what's the difference between malloc and calloc? Yeah, Mohit?
By mistake, my mic.
Okay, no issues. Okay, so the difference between malloc and calloc is that malloc will assign you one single chunk of memory, and it will assign you memory of however much size you want. Okay, a few things. It will not initialize the value to anything. Okay, so if there was like a negative 27 in memory location, let's say 8 before, it will still be negative 20 whatever in the new allocated memory. It will not be initialized to anything. And let's say that you request for 31 bits for some reason, it will give you exactly 31 bits. Okay, so if you know how much memory you want to use, malloc is the function that you'll be using for that. Now, in its place, calloc, it will assign you how many ever like number of items you want. It will assign you memory based on that. So let's say that I want 5 integers. So it will assign me the space that is necessary for 5 integers, and it will also initialize them to 0. Okay, so that's the main difference between malloc and calloc. So if you know how many elements you want in a particular array or in a particular uh, like pointer, in that case calloc is good. If you know exactly how much memory you'll use, in that case malloc is good. Okay, and if you want all the elements to be 0 beforehand, then use calloc. Is that okay?
Yes, sir.
Okay, so after that, which of the following statements islas are true regarding dynamic memory allocation? So can you guys tell me one by one if these are true or false? Both malloc and calloc functions are used for allocating memory at runtime. Is this true?
Yes, sir.
Okay, that is correct because malloc and calloc, that is the reason that they even exist. They are made to dynamically allocate memory at runtime. The malloc function also initializes the allocated memory chunks to 0. Is this correct?
No.
That's right. I just mentioned it, right? So which function initializes the memory chunks to 0?
Cannot.
That is correct. So this is false. The free function is used to release a specified block of memory. Is this true?
Yes, true.
That is correct. Okay. So let's just move on to the next one. What is the purpose of the free function in dynamic? Okay, we have just seen this one, right? So what is the function of free?
Release allocated memory.
Release allocated memory. Correct. So which among the following statements HLAS are true about dynamic memory allocation is? So just once again go one by one. Memory allocated dynamically cannot be released until the program ends. Is this true?
No, sir. We can free the memory within the.
That is correct. So we can free. So this statement is false. Memory allocated dynamically should be released using free to prevent memory leaks. Is this true?
So what we meant by the memory leaks?
So memory leak is when you overflow the allocated memory into memory that you should not be able to access. So in order to prevent that, uh, is this statement correct? Memory allocated dynamically should be released using free to prevent memory leaks? Okay, Suchita, you have answered. So, yes, this is true. Uh, if you have too much memory that is allocated at once, then you have a chance to, leak in access memory that you should not be able to access, and that is a serious runtime error. So, yeah, you should use free in order to prevent that. Okay. Next one. Dynamic memory allocation is in C is performed at compile time. Is it
No, sir. It's at the runtime.
correct? And finally, dynamic memory allocation provides flexibility in managing memory during program execution. This is true, right? So, next question. In which scenario using dynamic memory allocation would be particularly advantageous? So, when the memory requirements are fixed and known beforehand, when the memory has a limited memory, when the program has a limited memory footprint, sorry, when dealing with data structures of varying sizes and uncertain quantities, when the program utilizes only stack-based memory. So, which of these four is suitable for the use of dynamic memory allocation?
When dealing with data structure.
C, that is correct. Since if we since we are only allocating the memory if we do not know how much memory we would need. If we already knew how much memory we need, then we can just assign everything beforehand and we would not need dynamic memory allocation. So, next question after this. What happens if the realloc function fails to resize the allocated memory block? So, what happens? Think about it logically. If it fails to resize the memory block, let's say that we originally had a uh, four integer sized chunk of memory, and we wanted to increase that to 8 integers. So, what would happen if we, let's say, only have six integers worth of space? What would happen?
It will leave it as it is.
That is correct. It will leave the original memory block intact. Yeah, Suchita, that's correct. Okay. So next, how many elements are there in a 2D array? Integer matrix 3, 4. Sorry, 3, 4. So how many are there?
12.
That is correct. It's simple, no? It's three what? 3 rows and 4 columns. So it will be three. Sorry, it will be 12. In a row, in a row major representation of a 2D array with base address p, where each element occupies w bytes. What is the memory address of ARRIJ if array is of size r by c? Okay, so it's telling in a row major representation of a 2D array. So we will count what is it called? We will change the columns first and then we'll change the row, right? So it will go like 1, 2, 3, and then 1, 2, 3, and then 1, 2, 3, like that. So in that representation, if we have size r by c, so what will it be? Like we have r, we have c. So how many elements will we have? Okay, no, sorry. It is asking what is the location of the memory. If you can remember, in the last class we did something similar to this. If I bring up the flip. One second. Just give it a second. So yeah, if you look at this, we have a pointer over here, and this is a matrix. Right? We have a CR matrix right here, and we have this one. Right? So we have solved a problem like this before. So take a moment and try to solve this one. Okay? And ignore this one. I just did. So just ignore that one. And the next question is also the same exact thing. So if you answer one, you'll be able to answer the other. Okay, just if you need time to calculate, I'll give you 3 minutes. So I'll wait till 6:30, and after that, I'll just answer. Okay. Okay, so I'll just answer it right now. One second, let me just. Yeah. Okay. So is the annotation visible? Okay. Just give me a second, please, while I connect the pen tablet. Yeah. Okay, so let's say that we have this. What do you call? Okay, the pen tablet is. It is not want to work for some reason. Okay, ignore that one. I'll just use the mouse. So let's say we have a number where it is three uh, three rows and four columns. Okay, it is three rows and four columns. You guys know how it is represented, right? Yeah. So we have three rows and four columns like this, and it is said that it's a row major operation. So what we can see over here is we'll have four columns. So 1, 2, 3, 4, and then we'll have three rows. Is that part clear? And in a row major format, it is stored in this one. So this will be stored like this first, and then it will come back here, and then it will once again go like this. Once again it will come back to start, and then once again it will go like this. Okay, so if we want to find the memory location of a certain address, in that case it would go uh, 0 0 0 1 0 2 0 3, sorry, yeah, 0 3, and then 1 0 1 1 1 2 1 3 2 0 2 1 2 2 2 3, right? So notice every time that the row changes, we are looping back, right? But we also want to go ahead one. So what happens actually is when we are taking the what's it called row, we are multiplying it by the number of columns or the current column, I guess. So what we have to do is we change based on the row. Okay, so already you can eliminate the column based ones since they change based on column. So it would change something like this. Okay, it will change based on the columns, but we are changing based on rows. Now what happens here is we have four of these per row, right? So row size we already oh, once again I think I may have made a mistake over here. uh, yeah, sorry, that's my bad. Yeah, so since we have to count the number of columns, uh, actually, yeah, no, this is correct. So we have the column size, right? So we have four columns in each row. So we can eliminate this one and we can eliminate this one. Since these are counting based on the rows. So every time we complete a row, it would move on to the next one. So now we already have our C, right? So what do we have to multiply C with? This is the column size, or yeah, this is the column size. So we multiply this with the current row, and we represent row with I, right? So the current row multiplied by the column size. So what would that be? Let's say that we are in row 1 right now, right? So what would it indicate? We are at memory location, uh, column size, let's say it's 4. So 4 times 1. So 1, 2, 3, sorry, 0, 1, 2, 3, 4. So we reach at the correct location. That's correct, okay? Now we just need the column number plus j, okay? Since this part, it will point to the beginning of this one, and this part will help us move along to the position that we actually want, okay? So the answer that you said, that is correct. One second. This answer is correct. Option B is correct. Now, question 9 has anyone solved? I'll give you just 1 minute for that one, okay? It's currently 6:36. I'll just wait till 6. Okay, it's all. Yeah, I'll wait till 6:38. Give me your answer quickly, okay? Okay, so I'll just answer the question. So in the same way that we concluded with this one, this is just the opposite. Okay. So instead of row, we'll be taking column, and instead of the ij, we'll just exchange those. Okay. So this is the correct answer, option D. Okay. So let's just move on to the next question. Include PTR. Okay. How much of memory will be allocated to PTR, assuming the program runs on a 64-bit architecture? Okay. So, how much will be allocated to PTR? I don't know why they have. Okay, they have given in bits also. So be careful about your answer. It is multiple correct. Am I audible, you guys?
Yes, Babe.
Yeah. Okay. So just try and solve this question. Okay. Okay, can anyone tell me what is the size of an integer in a 64-bit architecture?
4 bit.
It is 4 bytes. That is correct. Now, can anyone tell me what are we taking the size of in this case?
Integer.
Okay, so we are taking the size of an integer, and we are taking how many integers?
4.
4 of them, right? So, what is the size of the memory that we are requesting?
16.
That is correct. It is 16 bytes. But there's a multiple correct. So, look at the options and tell me what other option is correct. That is correct, Suchita. It's 128 bits also. So these both are the correct options. After that, the next question we have a 3 by 3 matrix in star pointer 3 equals array. Okay, so it is okay. Can anyone tell me what we are declaring over here? Just try and guess what we are declaring over here with this. Where's my cursor? With this one. Like this part. Can anyone tell me what is this?
We are finding element.
Sorry.
We are finding the element from the matrix.
Uh, Not exactly. This is a declaration. This is not anything that we are finding. Okay, so see, this is we are declaring an array of pointers. Okay. Now this may seem a bit redundant, but this is an array that stores pointers. Okay, so if we had to come down here, what should the value question mark be replaced with so that it displays 8 as the output? So where is 8? 8 is what? 1 comma 2, right? So ARR 1, 2. That will give us 8. Am I correct?
So I didn't get this.
Okay, so see. Uh, we have this array, right? A multi-dimensional array. We want to see what values, for what values we will get 8 as the output, right? So let's say that we are taking ARR uh, IJ. So what should I and J be such that we get 8? Anyone? We can go with option A. Uh, can you tell me why say? Like I am. Uh, okay, sure. Let's just solve this. So we have a star pointer tree, right? So we have two parts over here. We have a pointer part and an array part. So can anyone tell me what the position should be in the array such that we get 8? Because that's the simpler one. Like what's the array of, sorry, what's the address of 8 in the array? That's correct, Sayyid. So the position that is required for us to get 8, it is ARR 1, 2. And by that logic only, we can print the same using the pointer. Since this pointer array stores the pointers first, and then it will store the what do you call? It will store the first. It will store. Sorry. It will store the rows first, and then it will store the columns. So it will store the whole element's address first, and then it will store the individual elements or the address of the first elements. Okay. So it is a bit tricky in this case, but yeah, just treat it as you would an array and it should be fine. And we have done quite a few pointer arithmetic. So this is simply pointer arithmetic. It is nothing else. Okay, next we have a decent size code. So starting in B int C A plus plus B plus plus star B plus plus star S plus plus. Okay. So can anyone tell me uh, what is A in this case? Can any can anyone tell me what is A in this case? Okay, so it is not a function. It is a variable only, but it's a global variable. Okay, it is accessible by any part of the function or any part of the program at any point. Okay, and it can be changed by any part of the program also. Okay, so when you declare a variable outside of any function, it is considered as a global function, global variable, sorry. Okay. And similarly, in start p is also a global uh, pointer. So now we have the int main. We can deal with foo later. We have main int d equals 0, int start q equals malloc size of int. Okay, q, the value is assigned to be 0. uh, int star, so we are taking another pointer as and a, so we are taking the address of a, and then we are taking what, p equals address of d. Okay, so quite a few things are happening over here, but the easiest way to see what happens is to make a table and to keep track of it. So I'll just open up a notebook over here. Okay, so is my screen visible?
Yes, Bhaiya.
Okay, so I have a notebook over here. So we can just keep track of everything in this notebook. So we have a equals 0, and we have p. I'll just do it like this. Uh, and a equals uh, something, and then we have p equals something, and then we have d equals 0. One second. Uh, okay, sorry about that. So I was saying the value of d, it is initialized to be 0. Uh, the value of q, q has been allocated, but we do not know the value, right? Okay, so we have allocated the value of q in the next step. So q is equal to 0. So star q is equal to 0. After that, we have r. So r is equal to and a. Okay, and then we have p. Okay, so we have allocated p as well. So now p is and d. Okay, so we had to do all of that in order to keep track of what is going on in the function. So now we have this list, and it is messy, but it is at least complete, or at least as complete as we can get it. So now in foo, we are giving in this one. In foo, we are giving this one. So now what will that give us? We have defined that as S, right? So we'll be getting S equals Q. So now what do we get? We have static in B. Can anyone tell me what static does? Can anyone tell me what is static? Okay. What does it do? It's a keyword, that's correct. But what does it do? Okay, so see, what static does is that it will retain the value between function calls. Okay, so notice that we have called the function twice over here. So what it will do is that right now it's 0, right? But the function will run and it is getting incremented. So at the end it will be 1. But since it is run again, now the initial value will not be 0, it will be 1. Okay, so the previous value will be retained. And now it will be printed out. It will be incremented, then it will be printed out as 2. Okay, okay. So, okay, now we have to do something else. Now, over here, let's just do this. From the below list of pointers, select all the pointers that will point to a memory address in the stack at some point of time in execution of the above program. So, do you guys know the distinction between heap and stack? Guys, can anyone tell me what is the heap? It is a term in dynamic memory Uh, okay, so can you tell me what what variables are stored inside the heap?
The malloc, calloc, and veloc.
Sorry.
Like the malloc, calloc functions.
Right. So it stores the dynamically allocated memory. Yeah. So using that, can anyone tell me what options can we immediately select? Can you tell me what options we can select immediately?
With the ampersand one,
Sorry.
the ampersand options.
See, be careful about this because we have pointers as well as variables in this. Okay. For example, d over here it is a variable, but q is a pointer. So if you do and q, you'll get the address of the pointer, not the address of the value. Okay, so be careful about this. No doubt, all of these are pointers, but you have to be careful about which pointer you are selecting, or are you selecting the pointer of a pointer? Okay. So tell me the most obvious one. As you said, dynamic memory allocation is handled by the heap, right? So which ones can we eliminate from this? Yeah, that's correct. It's a separate area of memory. But how is stack and heap different?
Stack arranged in cleaner way,
Sorry.
like stack arranged in more like cleanly.
Okay, so see, the stack it is just 1 second. Yeah, sorry about that. Okay, so uh, can anyone tell me what does a heap store? I believe that you mean functions, Suchita. That is true. The stack, it keeps track of the local variables. So can anyone tell me what are the local variables in this case? B, C, and D. That is correct. B is a local variable. Sorry, is B a local variable? Since we are using static and it gets modified repeatedly, can this be treated as a local variable? In C, okay, that's a local variable, and D is also a local variable. But what about B? Okay, so this was actually a trick question. Yeah, that's correct. As B is a static variable, it will retain its value throughout the program. And it is not stored in either the heap, it's stored in neither the heap nor the stack. It is stored in a static portion of the memory, which is completely different from both. Okay, so B is not stored in the stack. C and D, they are stored in the stack. Okay, so what we can do, C, D, we can just mark it like this. Now tell me, if something points towards C and D, can we also call that as pointing towards a memory address in the stack?
Can you repeat?
Yeah, so see, we now have determined that C and D are both stored on the stack since they are local variables. Now, can you tell me what pointers point towards C and D? Look at the pointers. Look at P, where is it allocated? P points to where? D, right? So it points towards the memory location of D. And since D is a local variable, where is D stored? It will be stored on the stack, right? So since the pointer P is assigned the address of D, P also points towards um, location memory in the stack. So B is correct. Did you understand the logic behind this?
Okay, sir, got it.
Yeah. So is there any other that is pointing towards the stack? Okay, can you tell me the memory location of S? Where is S pointing? Look at here. We are where we are calling the functions. So what are we putting in as a parameter for foo? For foo, we are putting in Q, right? So where is Q pointed? Like, what is the memory location where Q points? Where is it? Okay, so see, Q, it is getting allocated memory dynamically, right? So Q points to a memory location that is in the heap. Okay, so we do not want Q. Now the question is, Q in itself is a variable, right? It is just a pointer. So what is the address where the variable is stored? So what is the address where Q is stored? This may be a bit confusing, so bear with me over here. But Q points to a location in the heap. So it stores the address of a location in heap. Okay, that's different. What's the memory location of Q itself? Like in what memory location is Q stored? Guys, come on. Okay. So see, the actual like Q itself, it is inside of a function, right? So it is technically a local variable. Like Q stores the memory address, but it is technically a local variable only. So the address where Q is stored, it will be in the stack. What that means is, and Q is also stored in the stack. Did you understand this? Okay. So in a similar vein, is R stored in the stack? Guys, come on. Yes, sir. So see, R by itself, it will not be in the stack, okay? It points to A, which is a global variable. And global variables are not stored in the stack, okay? So R by itself, it does not point to a location where, uh, it does not point to a location in the stack. But the address of R, where the variable R is stored, that is in the stack. So and R will be in the stack, okay? So along with that, can anyone tell me where S is stored? Okay, so see, S is also, it is a parameter, right? We are inputting Q in the form of S, but that is also a local variable, right? So S is stored inside the stack as well. So and S is also a local variable. Is that understandable?
So can you explain it once more?
Okay, so see this. I understand if you guys don't get it. This is a bit like tricky since it involves multiple layers of pointers. But look at this in this way. Q by itself, it is like the value that Q stores. Okay, if you think about a container analogy, the object that the container Q stores, that is an address. That is, let's say, it's a map. Okay, but where Q is stored, that is different. Okay, so if we have something like this, so let's say that we have our 0 and Q points to 0. Okay, and 0 is in the heap since it has been dynamically allocated. Okay, but where is Q stored? Q is also stored somewhere in the memory, right? And since it is a local variable, Q is stored in the stack. Is that okay? So see, the value of Q, it points to this one. Okay, it points to the heap, but the address of Q by itself, it is stored in the stack. So Q is stored in the heap since that is the address of some value, but and Q, the address of the address itself, that is stored in the stack. Okay, so by that logic, since the address of Q is stored in the stack. The address of S is also stored in the stack since it is a local variable. Okay, so we have these many, and we can just check once to make sure that we are not incorrect. Okay, so we are incorrect. So according to this, P is not. Okay, so P was declared outside, so okay, that makes sense. But does it though? The address P contains it is of the. Okay. I think I understand. So the variables in the main function, they are not stored in the stack, it seems like. Okay. So yeah, that was my bad. The variables in the main function are not stored in the, but the variables in the local functions are stored in the stack. I think the variables of the main functions are stored in the heap or something. So yeah, so my bad. These both options are not correct, but the rest, the logic still stands. Okay. So I'll just refresh this once so that we don't get spoiled about the answer. Yeah. So these both weren't the answer. What is the output of the C program in question 12? So what is the output in this case? So notice that we do not have any, what is it called? We do not have any uh, new line statements. Okay. So whatever answer we get, it is going to be one solid answer. So like one integer. So can anyone tell me which line will be printed first? Which of these lines will be printed first? Can anyone tell me? Printf in the void. Yeah. So the function foo is called first. So this one will be called. Okay. So it is printing B and C, right? And notice here B is static, C is not static. So can anyone tell me what will the first value be? Like the first two numbers. See, this is how you have to approach the complex problems. Okay, there's no real two ways about it. Okay, so see, B and C are being incremented, right? So since B and C are being incremented, the and the initial values are 0, what would be the first two values?
1 and 1.
1, 1. That's correct. So what is printed next? This AD is printed next, right?
Yes, sir.
So you have to notice that A is a global function, right? So A being incremented, it is permanent. Now D is not being incremented directly, but notice that P has the address of D, and the value of P is being incremented. So can you tell me if D is being incremented in this one also? Come on, guys, think about it. Okay, so see, A is a global variable. It is being incremented, right? So A will become 1. D is being incremented through P. So it will also become 1. Okay. So the next two digits are 1, 1. Is that much clear?
Yes, sir.
Okay. So for the next one, I want you guys to answer. What will be the value of B and C?
Can you repeat, sir?
Sorry. Yeah. So what is the value of B and C in the second iteration?
They should be 2.
Oh, okay. And C.
I think C will be 1 because it is not declared in static.
That is correct. So C will be 1. Okay. So that is the purpose of this function done. Now tell me what is the value of R and Q over here. So uh, R, it is containing the value of A, right? Or the address of A. Okay, so can you tell me what is the value of A after the second iteration?
2.
It will be 2, right? Can anyone tell me the value of Q after the second iteration? about this is S is nothing but Q. We are inputting Q as S, right? So the value inside of Q is the same value inside of S. Okay, so if we are incrementing S, it is also incrementing the value inside Q, or the memory address that Q points to. It is incrementing that value. Okay, so after the second iteration, R is also 2, and like the value inside R is 2, and the value inside Q is also 2. So what will be 2, 2? Okay.
Yeah, okay, sir.
Okay, so let's just check it. I may be wrong, but no, that is the correct answer. Okay, so let's just see if we missed anything before. So yeah, it seems like we are correct on all the previous questions. Yeah, so only how many? This is 15 and that's 14. So only two more questions left. So let's just take care of that. And do you guys want to solve like a practice problem after this, or should we call it a day after this?
We can solve one.
Okay. So over here we have a missing code block. I'll just increase the size. Is this visible?
Yes, Bhaiya.
Okay. So we have a missing code block in this one, and we are given that the output is 654321. Okay. So we have been given that n is 6, and what do we have to do? Q of I equals I. Sorry, Q of minus I equals I. So what is it doing? Can anyone tell me? Have you guys had any experience with Python?
No, sir.
Okay, no issues. Just try to reason out what this minus I in Q is referring to, like which address position that is referring to.
Storing the decrementing value of I.
Sorry.
Storing the decrementing value of I.
I mean, see, it is storing something. It is not storing something. It is the address of something. Okay. The minus I is the address of something. So what will happen if we put minus I inside of a pointer? So what will happen? Okay, so see, if we have, let's say, 0 over here, what is that referring to? What is Q of 0 referring to?
First element of array.
That's correct. And if we go to Q of 1, what will that go to?
Second element of array.
Right. So what will happen? if I go to q of minus 1? Think about it. What will happen if I go to q of minus 1? Okay, so tell me what happens in the memory of this one. So we have, let's say, a memory location, what, k over here, and then we have a memory location l, m, n, etc., etc. And k is our 0. Okay. So what will happen if we go to 1? So if I do p of 0, it is k. What will happen? So what is p of 1?
L,
Yeah, p of 1 is l, and p of 2,
M.
it is m. Okay. But what is p of minus 1 now?
It will decrement by -1.
That's correct. It will go down by 1. And what is here?
O.
It is j. Okay. But notice that p only starts from here, right? So what's actually happening is that it is accessing the previous locations. Okay, it is going outside of its range, and it's accessing things that it should not. Okay, but we can use this since notice we are going back one and then we are incrementing by one. Okay, so see, we are going back one, we are incrementing by one, we are going back one, incrementing by one, back one, incrementing by one, back one, incrementing by one, and so on and so forth. Okay,
Yes, I got it.
so which of these codes is going to allow for that? Remember, q in itself does not matter, right? We are not using q for this one. We are deliberately going out of bounds in order to access the memory location that is behind q in order to get the answer. Here's a hint. Notice that we are printing p, we are not printing q. Okay, so notice that and tell me the answer.
Option A,
Option A is correct. Can you tell me why?
because when first we are implementing and then we Q has -I, so we are going back.
Okay, so see, the reason why we are doing this is because we have what's it called, p over here. Like p, it is the size of n, right? So can you tell me how many elements are present in p? Guys, That's correct. There are 6 elements in P. Okay. So, and then we are defining Q as P plus N. So what will be the memory location of Q? It will be six. It will be six elements ahead of P, right? The memory location of Q will be 6 elements ahead of P,
Yes, sir.
right? So if we are accessing 6 elements before Q, then what are we changing? We are changing P, right?
Hmm.
So that's why we are deliberately going out of bounds in order to change a different variable without, you know, implicitly accessing that variable. We are illegally changing a variable, you can say. So that's the correct answer. And finally, we have this one. We are creating an array. We are uh, we have an array. We have B. Okay, so why are we using B over here? Okay, see, there's something wrong with this one over here. Just from what I can see, there are two semicolons. So I don't think that this code would function normal, or it may just function. I don't know. I don't think that two semicolons next to each other are is an it is a syntax error. At least I don't think so. So we have int main over here, n is equal to 5, int a equals create array n, and then I equals, okay, so we are assigning the value like that, 0 1 2 3 4. Okay, and then we are printing that. Okay, so we just need this one, that inputting n over here, a is there. Okay, so what are the implementations that will work? I'll give you guys a few minutes. Right now it's 7:44. I'll give you till 7:55. So just try and solve this one, okay? Okay, Shahid. So let's just see what happens. Okay. So you say C and D. So we have an array. We want to create an array. Okay, we just need to create an array and return the array, right? So we are given an array of size n. So let's see the options that you suggested first. We have create array int n, int k equals int star malloc size of int n. Okay, that is okay. That's also okay. Like we are just eliminating the middleman step. So why is this not correct? Like it's also returning an array, right? Okay, see, this is also creating an array, right? We are creating an array and we are returning it. So this is also correct. So tell me, is this correct or not? Yeah, that declares an array on the stack. No, malloc does not declare an array on stack, right? Oh, this one you're telling, yeah, it declares an array on stack. You're correct, you're correct. But this one, it declares a memory on the heap. Yeah. So why wouldn't this work? So let's just check the answer since we are running out of time. Yeah, you're correct. So can anyone tell me why this is not working? Okay, so see, we declare pointers using this. Okay, it will give us a data error, data type error. Since we are not,
Instead of integer, we declare pointer, no?
sorry,
Like we declare a pointer instead of integer. That's why it gives the error, no?
that is correct. We are we declare a pointer in this method. This is not a pointer. This is an array, right? So that's why it will return an error. Okay, so good job, all of you. That brings us to the end of the class. And yeah, hope to see you all on Friday. Thank you all for joining.